Today we will study about mutable references in Rust and how it can lead to a data race situation and what is the mechanism available in Rust which prevents data races at compile time. In the last video we had seen concept of references which enabled us to borrow resources without transferring the ownership. So the ownership remained in the original scope, and if any function expects a parameter by reference, then that it will be borrowing that resource, and then it can return the results back to the calling function, calling scope. But that did not allow us to change something. Like we have some string here and we passed it as a reference to some function f, and if f wants to mutate this, then it cannot do, because by default the references will be immutable. So making it mutable is not tough. You have to just add this, make the original variable mutable, and also this function signature will change. So earlier it was s ampersand string, that is it expects a string. Now it expects a mutable reference to string. And similarly, when passing here, instead of passing ampersand s, you will be passing ampersand mutex. And here you can change the value of s. So let's see it in the code. So we will comment out the old code. And this function expects a mutable string. And what it will do, it will append something to the original string. And now here, let's create a string. Better create it mutable, otherwise it cannot be mutated. And then we call change on it, and we have to pass it by mutable reference, and then let's print it out to see whether the string was actually mutated or not. And let's run it. So we see that the string is hello world, whereas in the original scope it was hello and it was modified in the change. And Rust ensures some restriction on the creation of mutable references. For example, it will prevent multiple mutable references in the same scope. So here S is a string, and this is a mutable reference R1, and we create a mutable reference R2. And when we use both R1 and R2, then it will give an error. So why is this restriction implemented in Rust? So the main reason is to prevent a problem called data races. So a race condition which happens when these three behaviors occur are called data races. So the first condition is that two or more pointers access the same data at the same time. For example, in this case, both R1 and R2 are accessing this string hello. So this condition is satisfied. At least one of the pointers is being used to write to the data. So in this case, it's a mutable reference, so it has the permission to write to the data. If both of these were immutable, normal references, then it would have been fine, because none of them are mutable. And there is no mechanism being used to synchronize the access to data. We are also not synchronizing it. So that's why it will result in compile time error, and it will prevent any such data race conditions. Data races cause undefined behavior and can be difficult to diagnose and fix when you are trying to track it at the runtime. So Rust prevents the problem from happening, because it won't even let you compile it if it has data race. But you can add multiple mutable references by changing the scope. So by that I mean you can have let R1 mute S. Let's say S was the same string that we are looking at. And then when this scope closes, R1 is no longer in this scope. And here you can create R2. So let's see this in the code. So let's create a function, reference check, and let S be a mutable string. And let's create a couple of references which are mutable. And let's use them. And let's call this function in the main. And let's run it. So it should give some error. Cannot borrow S as mutable more than once at a time. So at a time, you cannot have more than one reference. So what this means, we were creating two mutable references. So at a time, it says, so let's first get rid of this. So it's in one scope. And let's create another scope. So now we have separated out the scopes of these two. And now let's run it. So we see that both R1 and R2 are getting the value of hello. And one important thing to note about references is that their scope begins from the point they are initialized and continues till their last usage. So their last usage was here. So in fact, you don't need even these braces. So let's remove these. And now let's run it. Just to confirm that it's a different thing we are running. So let's see that R1 and R2 both get the value of hello and this symbol because R1 was declared here and its last usage is this line. So the scope of R1 has completed. And then we are creating a new mutable reference. So what happens if I copy this and paste it after here? Now the scope of R1 is till this point, till last usage. But before the scope of R1 ends, we have created another mutable reference. So again, we will get some error, the same error. So this is important thing to note about the scope of references. And it may be slightly confusing for you in the beginning, but you will get used to it when you use more and more of references. So a similar thing exists when combining mutable and immutable references. For example, we can have multiple immutable references. That's fine because none of the references are actually changing the value. So there is no data rest condition because the data is not modified. So here we have two immutable references. It's fine. But here in the same scope, we are creating a new mutable reference. So this can lead to data rest if we are using R1 after this R3 or even R2. If we use R1 and R2 before this R3 comes into scope, so if the last usage of R1 and R2 is before this R3 comes into picture, then that's fine because no data rest exists because none of the references will be modifying the data. It only comes after these R1 and R2 have finished their work. So just to for the sake of completeness, we can create a few immutable references. Let's make it immutable. So this would work because the scope of R1 is here. But if I move again this print statement after this, then again it will be error. Although here we have just one mutable reference and one immutable reference, but still this immutable is being used after this mutable reference comes into picture. So data race condition can still occur. So this is also not allowed. And then references scope, this I have already talked. So that was all for mutable references and data race in Rust. We will continue our discussion on ownership principles in Rust, and we will see about slicing in the next video.